Every day, more than 100 million Lego bricks are made. That's roughly 1,200 per second. But each of these tiny bricks begins the same way, as a forgettable grain of plastic. And yet, what that grain becomes is anything but ordinary. Since 1958, Lego has perfected this process, ensuring that a brick from 1965 still clicks perfectly with one made today. This consistency is no accident. It's the result of meticulous engineering and a factory process that blends science with craftsmanship. Let's find out how a Lego brick transforms from raw material to the final piece. The journey begins in massive silos filled with tiny plastic pellets, made of acrylonitrile butadiene styrene, ABS. ABS is chosen for its durability, safety, and resistance to fading and warping. Lego offers over 60 engineered colors, each mixed to precise chemical formulas to ensure uniformity across global production sites. Before production, these pellets undergo rigorous quality control to detect impurities, color inconsistencies, or moisture, anything that could affect the final product. Only flawless pellets proceed to the next stage. The pellets are fed into massive injection molding machines, where they are heated to approximately 230 degrees Celsius, 446 degrees Fahrenheit, until they melt into a viscous liquid. This molten plastic is then injected under high pressure into precision-engineered steel molds. These molds are crafted with microscopic tolerances, just 0.002 millimeters, to ensure that bricks manufactured decades apart fit together seamlessly. Each mold can produce thousands of bricks per hour, with a single molding cycle taking less than 10 seconds. After molding, the bricks pass through cooling zones to stabilize their dimensions. Even minute warping can compromise the iconic click Lego is known for. Each piece undergoes thorough inspection, visually, mechanically, and sometimes digitally to identify defects. Lego's quality standards are stringent, with a rejection rate of about 20 parts per 1 million. Defective bricks are not discarded. Instead, they are ground down and reintroduced into the production cycle, minimizing waste and maintaining material integrity. Not all bricks are plain. Minifigure faces, tile emblems, and dashboard prints require micro-printing techniques. Lego employs advanced printing systems that layer non-toxic, child-safe inks with pixel-level precision, ensuring that each design element is accurately placed. This multi-pass process involves applying each color and detail in separate stages, using mechanical jigs and optical sensors to align the prints perfectly. The inks are engineered to resist rubbing, UV fading, and detergent baths, ensuring longevity and durability. Imagine building a 2,000-piece set. Somewhere, machines must collect exactly 2,000 specific pieces and package them so your instruction booklet doesn't send you on a scavenger hunt. This is achieved through a sophisticated system of conveyors, barcode scanners, weigh stations, and robotic arms. Scanners read part IDs, vision systems confirm prints, and automated counters ensure the exact number of each piece is added to a set. The choreography is astonishing. Components routed from diverse production lines converge into a precise assembly stream. Packaging is more than containment. It's the first emotional touchpoint between product and builder. Inside the box, parts are arranged in recyclable paper bags, a move away from single-use plastics. Each pouch or compartment is designed to protect fragile prints and organize stages of the build. Instruction booklets are full-color, user-tested guides that not only instruct, but also enhance the building experience. Box design, art direction, and protective architecture combine to make the unboxing a moment of anticipation rather than frustration. Lego operates multiple factories across continents: Denmark, Hungary, China, Mexico, and Vietnam to meet global demand. Once boxed, sets are palletized, optimized to fill containers, and routed through distribution centers. Efficiency here isn't just cost-driven, it's ecological. Smart packing reduces shipping volume and carbon footprint. Timing is tight, with a batch moving from production line to truck or ship within 24 hours. In 2018, LEGO launched its first plant-based bricks made from sugarcane, a bold step away from fossil-derived plastics. This wasn't just marketing, it represented a long-term pivot. LEGO has publicly committed to making all products sustainable by 2030. They've attacked sustainability on several fronts: renewable energy powering factories, recycling discarded or defective pieces, and reimagining packaging. It's not perfect yet, but the roadmap is clear. Reduce carbon footprint, preserve the product's hallmark durability, and keep the play experience unchanged.
So this is my Lego storage room. I'd say there'd be over 600 to 700 of them stored inside this room. My kids aren't allowed in here. Probably could be stored better, but I have an air vent for ventilation and store a lot of them in cardboard boxes to keep the boxes in good condition. I know the retail value of the sets I've purchased is over $50,000. Secondary market value, I would suspect it's a lot more than that.
The promise LEGO made decades ago still holds. Parts last. Bricks from the 1960s, 1970s, or 1990s still fit today. That's not nostalgia. That's engineering discipline, tight tolerances, and material consistency. Over 600 billion bricks have been produced since 1958, billions of little connectors that have to work together across time and place. Durability means more than mechanical fit. Colors hold up, prints stay legible, minifigures maintain their personality. This longevity turns LEGO into an heirloom.
Like this 8-foot-wide Lord of the Rings build that took 11 years to construct.
I don't know how much it cost. It was definitely in the thousands. Like for me now, I'm done buying Lego. I feel like I have enough here.
I've been playing with it since I was a kid. I got my first set when I was 4 or 5. Good portion of the apartment is filled with Lego. When we buy a house, we'll very quickly have a Lego basement.
After heat, molds, inspection, printing, sorting, packaging, shipping, and sustainable pivots, the box opens. The parts scatter across a table. A child, a teenager, an adult builder bends over the instructions or throws them away and improvises. That moment is the point of the entire journey. Plastic granules become a vessel for creativity, learning, patience, and connection. LEGO is engineered to disappear under your hands. The machinery should never be the story. The story is the castle you build with a friend, the micro-city you construct for an animation, the quiet concentration of designing a model that took weeks to perfect.
LEGO is faced in new markets like China is that the grown-ups, the parents, just don't really know about Lego. They don't have Lego in their own backgrounds like a lot of grown-ups in the US and Europe do. Being part of these popular franchises like the Avengers, for example, is a great way for Lego to reach out to all kinds of different generations, people across the world, people who don't necessarily even know Lego.
So next time you hold a Lego brick, remember the journey. From ABS pellets in silos to $100,000 molds, from microscopic tolerances to plant-based experiments, every step matters. It's a story of precision, innovation, and responsibility. But above all, it's the quiet infrastructure behind millions of tiny adventures.